All right, this is 8.3, regular polygons and their areas. Okay, so here's some important vocabulary. We've already talked about that point Q is the center of a regular hexagon. So a center is just that point, just like a circle that's right in the middle. QE, which is this point, this line or segment over here, is the radius. The radius joins the center of the polygon to a vertex, so it goes here. QD would also be one, QC, QB, QA, QF. Now OG is the apothem. It goes from the center straight down perpendicular to that side length. Angle EOD, so this guy, or EQD, excuse me, this guy in here is the central angle. So central angle, again, just means the exact same thing that it meant for a circle. And so this is the vertex of the central angle. These are both congruent radii of the polygon. So if we look over here, we can find that the measure of a central angle of a polygon is this. If you think about it, what's going on right here is just a circle. So we're looking to see what fraction of that circle does it make up, and the whole circle is 360 degrees. So the radius of a regular polygon bisects the interior angle. So if we were to zoom in over here, then we would see that this angle would be congruent to this angle. This also tells me that the apothem actually bisects the side to that it's perpendicular to. So this side segment is congruent to this segment. So that tells us a lot of information. So that's what's being said right down here at the bottom. Okay, the area of a polygon with a length of apothem A and perimeter P is this formula right here. So if we look at this example right here, find the area of the regular octagon shown in this figure. The center is point O. The length of apothem OX is 12.1, and the length of the side QR is 10. So what we can do is we can focus on the information that's given to us. So if I know that this is 12.1 and I know that one side length is 10, I need to figure out, okay, first my perimeter is, well, I have an octagon that tells me I have 8 sides that are each 10 centimeters long. So that tells me that my perimeter is 80. Now when I look and say, okay, if I have my apothem of 12.1, I know my area formula. So area is equal to 1/2 of the apothem, so 12.1 times 80. So that's something like 40 times 12.1, and then we can make that into a number, which is 484. Now this is where units are important. That's going to be centimeters squared. Here's the solution if you want to take a look about how they did it. Okay, some important things to remember. SOHCAHTOA, we need to remember what sine, cosine, and tangent are. Remember, we do not do sine, cosine, and tangent of 90 degrees. Never, ever, ever. So no using law of sines when you have a 90-degree angle. So I'll write that real big. No law of sines if have 90-degree angle. The same thing can be said for law of cosines. Now, so sine, cosine, tangent, when to use them, how to use them. Isosceles triangles. Remember, if we have a triangle with 2 legs that are congruent, those base angles have to also be congruent. And then remember your special right triangles, your 30, 60, 90 triangles, and then your 45, 45, 90, and how those work. So if you don't know those, draw them out, practice, and then we'll come back tomorrow and use all of this information as well as what we've learned about polygons in order to solve some problems.